right? So this is about Crystal and Alexa. And we know that Crystal's 12, right? And Alexa is 6. And the rule for the way they share is kind of like what happens at your house probably. Older kids get more, bigger kids get more, they get this. It's different rules for different ages though, right? Sometimes, not always. Like sometimes if you're older you get to stay up later. Okay? So in this problem, the bigger kid gets more candy. Okay, so maybe it's like a 6-year-old and a 2-year-old, right? That would make sense if the bigger kid gets more. So a 12 and a 6-year-old, that still makes sense. Okay, so when I look at the problem, and I get to just go back and look at it, it says that about Crystal, she's 12, Alexa's 6. So you have this in your book on page 46. I'm not going to read the whole thing. But I am going to look down here, and it's asking us how would they share a 9-segment chewy fruit worm. So just the basics. If they share according to their age, there's 2 ways to do this. You could do their names in a ratio table. And then the total segments. And so, and then maybe put a picture to it. So these would be good notes for you guys to take. So the total segments is 9, a 9-segment chewy fruit. And then what would you get, Kate? Or what's your question, Caden?
Well, when I was reading it, I sort of didn't understand. I thought they were supposed to like share equally, like the 9 segments.
Okay.
And so I was like, oh, it's 4.5 for each.
Right, but what they really meant is for you to take this, and one person gets twice as much as the other. So what they really mean is we kind of want to look at it like this, where Crystal, you know, gets this much.
She gets 6.
And Alexa gets that much.
So Crystal gets 6 and Alexa gets 3.
Well, that's right. I'm hearing the right answers. I think I should have done a better job starting. I think I should have put in the fact that we are using the ratio of Crystal to Alexa being 12 to 6, right? And so that ratio, if there were say 12 pieces for Crystal, like the book talks about 18 segments at first, 12 plus 6 gives you the 18 segments, right?
Yeah.
They're asking what if there's 9 segments? So this is just division, right? And so this would be division. So 6 divided by 2 is 3, and 12 divided by 2 is 6. So your picture for that one would say there's 9 segments. So each one of these, if you were going to do a picture, would be, you know, like, that's Crystal, and this is Alexa. Do you get that?
Yeah.
Okay. So that's the thinking. That's what that page is just getting you to think about. So then they say there's a 2-to-1 unit rate. If you read a little bit more, because if I divide both of these by 3, do you see you get 2 to 1? And there's that 1 again. Every time that 1 appears, there's like a unit rate. So there's 3 whole parts. That's true. But if I wanted to make a sentence about this, I'd say for every part or segment, for every segment, Alexa gets, I was going to say, but we'll say yours too. Every segment Alexa gets Crystal gets 2, right? So every segment singular, Crystal gets 2 segments, or double, right?
Yeah.
So that would be correct. But Peter said a different unit rate. He's now divided by 2, which gives us a 1. And remember, fraction bars mean divide. So for every segment Crystal gets, we can write a different sentence, right? For every segment Crystal gets, Alexa gets a half segment. Understand that? Okay. So let's go to the next side. It says draw some chewy fruit worms with different numbers of segments that Crystal and Alexa can share without having to make new cuts. Well, do you remember the original one had 18 cuts? So remember, like, draw some chewy fruit worms with different numbers of segments. Oh, so basically they're just saying, if you look at your ratio table here, could I draw a chewy fruit worm with 3 segments? If I did a chewy fruit worm, so for part A, with 3 segments, then I would show that Crystal gets these and Alexa gets that. Does that make sense? Could I do a chewy fruit? We already did 9, so can I turn this into maybe 6? So if I had a chewy fruit worm with 6 segments, instead of just 3 segments, it would be like 2 of these, right? So when I did that, uh-oh, it all ungrouped on me. So I could do a 6-segment chewy fruit, and yeah, you could leave it the way it is, or you could say, you could see that Crystal gets 4, right? So you could write it this way. Crystal gets 4, and Alexa gets 2, or you could do it with color shading. And Alexa gets the blue ones. But if you look back at the ratio table, if this is 6, I had to double, didn't I?
Yep.
Which means I would have to double here, which gets the 4, and I'd have to double there, which gets the 2. See how to use that ratio table?
Yeah.
Okay. So part A is not too bad. Let's look at part B. Okay, part B has to do with David and Peter, right? Or is it Jared? Okay, so let's read part B. Jared is 10 years old. His brother Peter's 15 years old. What are some chewy fruit worms they can share without having to make new cuts? So if we go to a ratio table, Jared's 10, Peter's 15. So how about just a 25 one? We could do one that's 25 units long, right? What's another one, Wyatt?
I could well, one could be 8 ball.
8.
Yeah.
How'd you get that? Good.
Well, I did. So what I did was I just started out with the smallest one you can have, which is basically if he gets 3, since they're both multiples of 3, I put it in as 15 is or 15 divided by 3 is 5. Or sorry.
Let's see if we can see what you're doing. Maybe can we try to see if we can get your answer by dividing by 5, just so people can kind of follow along? This would be 2 and 3, right? And if I divide each one by 5, I should get a 5 down here, right? So 25 divided by 5 is 5. 15 divided by 5 is 3. And when I add 2 plus 3, I get 5. So I can see a 5 segment one.
Yeah, so, 10 segment,
Yes, okay. But
and
do you see how the ratio table can help kind of eliminate that confusion? Like just listening to what he said, by me writing it down, we could catch his mistake or he could find it?
yeah, I wrote it down as 10,
That's okay, so let's just look at it. One would be a 5 segment chewy fruit where Jared would get 2. So you could show your work like this and Peter would get 3. Does that make sense? That's a P for Peter. Or you could do 10, he doubled. Okay? What's another one, Sean? So you guys are talking and I can't help you with your homework when you talk to your friends. It just doesn't work. So even if you're talking about this, it works better if you try to listen to what Wyatt was saying. Right? So, Sean? And we did, right? Yeah. Yeah, so for this one though, you're right, you would have a 10 segment. So again, you guys, you want to stay on task so you don't miss things. I'm going to try to break this into 5. And then 5 again. So 10 segments. Jared would get 4. Peter would get 6. You see that? Okay. Carson. Yeah. You could. You could multiply by, somebody was just about to say that, like by 3. So 12, 18, 30. And these two should add to this, shouldn't they? 12 and 18 make 30?
Yes.
Okay. The other thing you could do is you could add columns. Because what's 2 plus 4? 6, right? And what's 3 plus 6? 9. And 5 plus 10 is 15. And the reason that works, watch this. What's 5 times 3?
15.
What's 3 times 3?
9.
What's 2 times 3?
6.
So adding columns works too. It's nice, isn't it? Okay. So let's go to B part 2, because that's 2 examples for B part 1, right? So B part 2 says for each worm you described in part 1, write a ratio comparing the number of segments Jared gets. You want to do a Jared to Peter ratio. So Zoe, what's the Jared to Peter ratio in this worm, in worm 1? Nice, 2 to 3. Okay, so Ryden, what's the Jared to Peter ratio here? 4 to 6, right? And look at, here they are, 2 to 3, 4 to 6, right in that ratio table. Okay, so that's B part 2. So even though that was B part 2, I didn't really have to do any other work. All my work was from the table. B part 3 says, are the ratios we wrote in part 2 equivalent to each other? Is 2 to 3 the same as 4 to 6? Yeah, they're all in the same ratio, aren't they? So B part 3 is already done. What about B part 4? What's that about? How would you write a unit rate to compare how many segments Jared and Peter get? So we want to figure out, like, what if this is a 1? Yes.
I was gonna do 2 and 3.
Talk to me and say that again.
I
I was gonna do 2 and 3 and 4 and 6 again. So can I do that?
Tell me yes.
So it would be 2 over 3, like,
Yes.
and then 4 over 6. Or you could do
Or,
2
um,
slash 3
okay.
slash 5.
Well, not exactly. I get what you're saying. Okay, so what they're saying is, let me think about this. Let's reread that again. How would you write a unit rate? Tell me your idea again. You were going to put,
4 over 6.
okay, we have that, right?
Or you could do the slash, like,
Okay, I see what you're saying. So I think we should look a little bit over here, kind of put Jared and Peter in a smaller table, just because there's so much to look at, and go back to this picture where Jared gets 2 parts to Peter's 3. Do you guys see what I just did? Okay, and what she's saying is if Jared has 1 segment, is that what you're saying? We would have to divide by 2.
Yeah.
Do you guys agree with that? So then when we divide 3 by 2, we get 1.5. Or, she said, 3 halves. They're the same. So, Allie, that is what they're asking. So then a sentence would be, for each segment Jared gets, Peter gets 1.5. That's one way to do it. Let's finish up with the last way. What if I put the one, you guys are doing well, what if I put the one, I go back to Jared and Peter, and instead of having the 1 on top, what if I put the 1 here? What would I have to divide by? 3. Good job, Kate. So, to divide 2 by 3, we're going to just put 2/3. You get that? So for each segment Peter gets, what does Jared get? Yeah, Jared gets, does he get a whole segment if it's 2/3? It's 2/3 of 1 segment, right?